Good morning to all. Today we are going to discuss some more questions which are related to functions, and this theory will be helpful for solving multiple questions or one mark question, or you can say fill in the blanks. So this is very important. You just see what the things is written on the board. Now I am explaining the things. First of all, it is written, let A and B are two finite sets. It is from A to B, means A and B are two finite set, and f is a function from A to B. Then we having some points, we have to take it as a note. It is very helpful for multiple questions, or we can say very short type, or we can say it is helpful for fill in the blanks. Now if f is an injective, that means 1 then number of element which is present in set A is less than equal to number of element present in set B. Means if it is, you have two sets A and B, and it is what, finite, means it has some element. Suppose A, B, C, and this is P, Q, R, S. So here this condition is present, what, number of element present in this set which is less than number of element which is present in set B, and f is a rule, then this function is always 1 and if it is equal also, then also it is 1 Why? Because A is related to P, either A related to Q or A related to R. Similarly, all are related to each one of the elements. 1-to-1 correspondence is there. So if P, Q, R, S, if all the elements present in this set and number of elements present in this set is less or equal, then it is always 1 or injective function. It is clear? Now, second point is, if f is a surjective, that is onto function. If it is onto, then number of element which is present in set A is greater than or equal to number of element which is present in set B. Means number of element present in set A, means this is set A, this is set B, and f is a rule which is from A to B. Now number of element, either both are equal, suppose A, B, C, and here it is P, Q, R, then it is 1 above, from above definition it is 1 and now here if it is equal, then also it is 1 on 2. Now if it is greater than P, A, B, C, D, then it is always on 2. Why? Because here any two elements is related to one of the elements, either it is related to P or related to Q or related to R. So the main thing, if number of element is greater than, this set is greater than, that means number of element which is present in set A is greater than number of element which is present in set B, then it is always onto function. Third point number 1, it is clear, 2 is clear, and now the third is what? Bisective. Bisective means what? 1 and onto. So in this case it is always equal, means both set having equal number of elements. Suppose f is a rule which is from A to B, so A, B, C, and here it is P, Q, R. So this related to this related to this related to 1-to-1 correspondence, then it is always 1 and onto, that is bisective. Means number of element which is present in set A is number of element present in set B, both are equal, then it is what? 1 and onto, that is bisective. Now next point on head, on this point we having 3 points. Now in this point we having, I written here 2. Now you see, if A and B are two finite sets, if A and B are two finite sets containing m and n elements respectively, means number of element present in set A is m, number of element present in set B is equal to n, then number of functions from A to B, means this set containing, F is a rule, this set containing m number of elements, m number of elements, and this set containing n number of elements, then total number of function is what? N to the power m. This you have to remember, n to the power. Here the concept coming from permutations. Now you see what is there. Suppose F is a rule from A to B, and this set containing A, B, C, and this set containing P, Q, R, S. So number of A is how much? Number of A is 3. Number of B is how much? Number of B is 4. Now, how many functions? Number of functions from A to B, n to the power m. This set containing m, this set containing n. This set containing m element, this set containing n element. Then answer is n to the power m. So here what is n? 4. 1, 2, 3, 4. And what is m? 1, 2, 3. So 4 to the power 3 means what? 4 to the power 3 means what? It is what? This number of functions will be there. This much number of functions will be there. So you just multiply and take the answer. 64 into 4, 216. No. 256. This is the answer. Now 256 means what? 256 number of functions will be there. So be careful. If this set containing m number of element, this set containing n number of element, then total number of function is n to the power m. Okay. Now one more point is there. You just see first this one. Total number of onto function. Total number of onto function from A to A means set F is a rule from A to A. So what number of element present in this set, and here both are same, then the number of onto function is n factorial. Suppose this set containing n element, then automatically that set also containing n element. So number of onto function is n factorial. That is written. Number 3. Number 3 means third point. This is first, second, now third point. Number of onto, sorry, 1 1, number of 1 1 function from A to B. This is what? It has two conditions. NCM, this is a combination into m factorial if n is greater than equal to m, and number of 1 1 function is 0 if n less than m. Why? Because 1 1 means every element of first set having distinct element, means two distinct element having two distinct images, then it is 1 1. Suppose why it is 0, that only I have to that point I have to explain. This is m, A containing m element, B containing n element. F is a rule. So if here n is less means A, B, C, D, and here it is P, Q, then it is never 1 1. That is why the number of 1 1 function is 0. Why? Because it has 4 elements, and here the images are codomain containing 2 elements. So either all the elements related to one P or Q, or 3 related to P, then D related to Q. That means it is never 1 to 1 correspondence. That is why number of 1 1 function is 0. But if it is equal or greater, then the answer is NCM into m factorial. Next point, number 4. Number of onto function. Number of onto function from A to B. First is summation r equal to 1 to n to 1 to n minus 1 to the power n minus r n c r and r to the power m if m is greater than equal to n, and it is 0 if m less than n. Means number of onto function is 0 if m is less than n. So these are the formulas what I written today. This is very important, and 1 mark in 1 mark questions, some of the questions will coming from this slot only. So be careful, you remember all the points. And now some more questions which are related to function. Now the question is, let a equal to r minus 3. One set is there. In that set, real number except 3, and b is a function, b is a set which having r minus 1. So minus, this is a, this is b. Actually it is r and it is r, but when we take out that number 3 from here, then this is taken as a, and from here 1, if you remove 1 from here, then it is b. So that is why in our basket 3 is not present and answer 1 is not present. So that is why instead of writing rr, it is written a and b, because r minus 3 is taken as a and r minus 1 is taken as b. After that, and rule is if it is a function, then rule is always defined. I told function is nothing, it is a rule, and rule is always defined. So the what is the rule? So the rule is f is a function from a to b. F is a function from a to b such that f of x is equal to x minus 2 by x minus 3 for all x belongs to a. Prove that f is bijective. Bijective means 1 1 and onto. That is 1 1 and onto. We have to prove it is 1 1 and onto. Now for 1 1, now why it is written r minus 3? Because if fx is given by x minus 2 and x minus 3, so if we take 3, then 3 minus 3 will become 0, and anything divided by 0 is not defined. So in our basket, that 3 is not present. If I can remove that 3, then the function is always defined. So that is why in domain 3 is not present. Now for 1 1, I told so many times, for 1 1 two distinct elements we have to take from the first set. Now let x1 x2 belongs to a, x1 and x2 belonging to set A, then images should be equal. F of x1 equal to f of x2. If I taken these two are equal, this implies what is f of x1? fx is equal to x minus 2 by x minus 3. So x1, if you take x1, then x1 minus 2 by x1 minus 3. if you take x2, then x2 minus 2 by x2 minus 3. It is clear? Now f of x1 means x1 minus 2 by x2 minus x1 minus 3, and if it is x2 minus 2 by x1 my x2 minus 3. Okay, now cross multiply x1 minus 2 x2 minus 3 equal to x2 minus 2 x1 minus 3. This is x1 x2 minus 3x1 2x2 plus 6 x1 x2 minus 3x2 minus 2x1 plus 6. Now any cancellation, just cancel it. x1 x2 cancel, 6 cancel. This implies minus 3x1 plus 2x1 equal to minus 3x2 plus 2x2. So this is minus x1 equal to minus x2. Minus minus cancel. So x1 equal to x2. Only one solution. So what it is? Images are equal, elements are equal. Means two distinct elements having two distinct image. Therefore f of x1 equal to f of x2 implies x1 equal to x2 for all x1 x2 are the member of set A. So f is 1 1. Why? Because we have to prove bisective. Bisective means I have to show it is 1 1 and 1 2. So this is 1 1. So f is 1 1. Now we have to check it is on 2 or not. Four on 2. 4 on 2. So 4 on 2, what we do? We have to take second one arbitrary element, let y belonging to set B in second set. In by proving for proving 1 1, we have to take two distinct elements from set A. But if we have to prove on 2, then we have to take one single arbitrary element from set B. Now y belongs to B. B means codomain. That then y equal to fx equal to what? X minus 2 by x minus 3. This implies what I told earlier. Write the independent variable as a dependent variable. Here it is y dependent, x independent. Now we have to write the value of x in terms of y. So xy minus 3y equal to x minus 2. So this implies now we have to write the value of x in terms of y. So bring this x 3y minus 2. So this implies x y minus 1 equal to 3y minus 2. So this implies x equal to 3y minus 2 by y minus 1. Value of x in terms of y. Now what is x? 3y minus 2 by y minus 1. So in set B, why it is written r minus 1? If that means in answer in range 1 never come. And if you see, if I take y as a 1, then this x is not defined. Why? Because 1 by 0 not defined. That means y is not present. So if you take, since y is not present in this, y is not 1. If you take y as 1, sorry, x as 3. Now we take x as 3. So if you write 3, then 3y minus 3 equal to 3y minus 2. So what happened? this implies this will bring this side 0 and this is 1. 0 equal to 1. Why it is coming 0 equal to 1? Because when I take the value of x as 3, then the then the result become 0 equal to 1, which is false. Which is false. That means x never 3 and y never 1. So that is why it is written here. And for onto what I have to show, I have to prove every element of this set B has at least one pre-image in set A. Otherwise we can show range equal to codomain. That means f of x equal to y. Now for each y belongs to B, there exists x a real number x belongs to A such that f of x is equal to what is x? X is 3y minus 2 by x minus 1. Now write in place of this x. So x means 3y minus 2 by y minus 1 in place of x minus 2 divided by 3y minus 2 y minus 1 minus 3. Now you solve. If it is coming f of x equal to y, that means your range is equal to codomain. F of this is 3y minus 2 plus minus 2y plus 2 divided by, the LCM will be cancelled. So 3y minus 2 minus 3y plus 3. Now you see this 2 to cancel, 3y cancel. So y and denominator is 1. So it is y. F of x equal to what? Y. So what I have to say, this function is onto y because range equal to codomain. So f is onto. So this is the required proof. Now you write. Some more questions. Let f is a function. First of all, a and b are two non-empty sets. Let a and b are two non-empty sets. Then f is a function from A cross B to B cross A such that f of AB equal to BA for all AB is the member of A cross B. Prove that f is bisective. You have to prove f is bisective. So how we can prove? You just see. Here it is a Cartesian product. So in this set, always the elements belonging to in form of ordered pair. Suppose this is a rule. F is a rule from A cross B to B cross A. If AB present in this set, then BA present in this set. Why? Because if AB belongs to A cross B, it means A belongs to A and B belongs to B. But if BA belongs to B cross A, same thing will come. B belonging to B and A belonging to A. only presentation is there, things are almost same. We have to take 2 for proving bisective. What I have to prove? First is 1 1 and second is on 2. So for 1 1, what we have to do? Two distinct arbitrary elements we have to take from first set. So the element belonging to first set in form of ordered pair means we have to take two number of ordered pair, two different ordered pairs we have to take first. Now for 1 1, let a1 comma b1 and a2 comma b2 belongs to a cross b. Then images should be equal. F of a1 b1 equal to f of a2 b2. The things is almost same, where earlier we have to take here taken x1 x2 belongs to a cross a, x1 x2 belonging to a. So in that place, suppose this is x, this is x1, this is x2. So x1 x2 belongs to x, same thing. So after that I have to take f of x1 equal to f of x2, same thing, f of x1 equal to f of x2. So if this implies f of a1 b1, so by definition what is belonging here, the things will be reversed. So this is b1 a1 equal to b2 a2. So what you observe, if two ordered pairs are equal, that means first component is equal to first and second component is equal with second. So this implies b1 equal to b2 and a1 equal to a2. So we are free to say a1 b1 equal to a2 b2 we can write. So what you observe, since f of a1 b1 equal to f of a2 b2 implies a1 b1 equal to a2 b2. So therefore f is 1 1. Now we have to check how to prove onto. In order to prove onto, we have to take one single ordered pair from this set. Sorry. Let for onto, let b comma a belongs to b cross a. So what it implies, b belongs to b and a belongs to a. Okay, that means AB belongs to A cross B. We can write, because A belonging to A, B belonging to the same thing. So for H BA belongs to B cross A, there exists AB belonging to A cross B such that f of AB is equal to BA. So what it is? Range equal to codomain. So if range equal to codomain, that means therefore f is onto. So f is onto means first of all f is 1 1 and here f is onto. So 1 1 and onto. Okay. Again